Hello and welcome to Cisco's Public Center Sector of Excellence. My name is Benn and I'll be leading you through a demonstration of our connected real estate and building automation systems. First, what I'd like to do is point out the different components that you see behind me here on our CRE panels. And starting over here on this panel, we have a collection of security devices that we would commonly see in a typical commercial building. So for example, we're probably familiar with these manual fire pull stations here that we would see around a hallway. This device is a gas sensor over here. This is an acoustic sensor that will detect blast break. This is the fire and smoke detector. This is a strobe alarm that will respond to any number of one of these devices that would trigger. And then down here is our main control panel for all of these devices. Moving over, looking at this panel primarily focuses on electrical devices. So on the bottom we have a smart meter and a relay switch. We have a standard light socket that's controlled by a light sensor. We have a thermostat and a thermometer here. And then we also have some other electrical control devices and some fans here along the top. Moving over to this panel, down on the bottom portion is our simulated HVAC duct to show what we can do in response to some of our building controls. In this area of the panel, this is our physical access control devices. We have the physical access gateway here. This provides a point of connection for things like the exit button, the combined card reader and door strike, as well as the keypad. This part of the panel up here, this is known as the mediator. This is from Richard Zeta, which has recently been acquired by Cisco. The purpose of this device is basically to aggregate a number of legacy building automation protocols, for example, such as BACnet, LANnet, Modbus, and so on, and mediate that or aggregate that onto the IP network using these connections that we see here. And then finally, over on this panel, we have a number of HVAC-related devices, such as these devices for hot and cold air with actuator arms to control dampers that might be up in the plenum area. This is a sub panel for the Richard Zeta mediator, and then we also have some thermostat devices here as well. So that's a brief description of what we have on our panels. What I can do now is take a minute to show you some of the things that we can do. So what I'll do first is I'll turn on our HVAC unit, and I can do that from an IP phone that you probably cannot see at the moment. And I'll set our HVAC on using IP phone services, and I'll initially turn it on. And give it a second here and we'll start to see some things glowing here in the simulated HVAC ducts. And so as we can see indicated by the LED that we're currently set to low on our HVAC fans, and we can also see from the tassels that we're actually blowing air out here and sucking it in here. Now in many traditional building environments, obviously we're certainly going to have some sort of HVAC system, we're going to have some type of security systems. Typically those exist as independent silos and don't talk to each other. One of the advantages of implementing a connected real estate solution on an IP-based network infrastructure is not only can we share the same IP infrastructure, but we can allow these systems to talk together and apply policy to these devices so they can leverage each other. A good example of that is, let's take a look at the HVAC system that's currently on. What if I were to step over to my fire alarm station and pull a fire alarm? If I've got a fire incident occurring within my facility, I don't want to be pushing smoke through the plenum.
Alert. Fire alarm activated at door 1 on the first floor. Please view the signage for evacuation plan. HVAC system deactivated.
And as we heard through the speakers and radios, the system is actually connected in with our iPic solution, which allows it to do automatic alerting and notification over the radios. You also hear a telephone ringing in the background. I'm also getting a notification from the telephone in a completely automated fashion as well. So getting back to my HVAC duct, the HVAC duct actually shut off in response to the fire pull station, because again, we don't want to be blowing smoke through the facility in the event that there actually is a fire. Let me just go ahead and reset the panel here. Okay, so I've reset that for now. I'll swing around and show you that on our digital signage unit, we actually have displayed a custom evacuation map via a digital media player also connected to the IP network. I can also swing around and show you the telephone that's ringing. And just as I did that, it stopped ringing. Taking a look at the displays at the front of the room, you can see the red desktop alerts that have popped up in response as well. That's our mass notification system from our partner known as AtHoc. And I'll leave the focus on the digital media player for a second, and we'll reset the alarm system.
Attention. First floor fire alarm has been cleared in 911. HVAC system resumed normal operation.
And as we heard from the announcement, the digital display, the digital signage unit is returned to its normal imaging, and we've also returned to normal our HVAC operations as well. So as you can see on the panel, we've returned the HVAC to its normal state now that the alarm has cleared. So there's a good example, taking a look at what we did with the HVAC system and the fire system, these systems working together because they're tied together via the IP network in a policy engine that determines what we should do in the event of a given alert. The next thing that we can do is we can take a look at our physical access control, and on physical access control we can actually simulate a door forced open alert.
Warning. Door number 1 has been forced open. Security has been notified.
So we heard an audible notification that a door was forced open, and that was in response to this toggle switch which was simulating that particular event, and that's going through the physical access gateway. I'll go ahead and turn off the HVAC unit from the IP phone. And another demonstration we can take a look at is with the lighting system that we have. So again, I'll go to my IP phone, and I can control the lighting here as well. And I'll just go ahead and set it to a low level.
Notice. Light level automatically set low.
As we heard from the announcement, I manually adjusted the light setting to low. Similarly, I can set it to high if I like.
Notice. Light level automatically set high.
And then lastly, I'll set the lighting to automatic. And what we can do on automatic is we can actually have the lighting respond to the amount of light that's actually in the room from this light sensor. So if I have a large volume of light coming in from the outside, or a large amount of natural light, what I can do is throttle back the electrical system so I'm not using as much energy. So I'll simulate some daylight by shining a light on the light sensor, and in a couple seconds here you can see it adjust down, and if I make it brighter it'll go off completely. So that is something we refer to as light harvesting, where we're taking advantage of natural daylight coming in from the outside. Now that I turned off my light, my flashlight on the sensor, you can see that it adjusted back to a high level.